everyone. Welcome to Calculus. This first whole chapter is all about functions. And so we're going to start off by learning, what is a function, which may be review to you, but that's okay. So we're going to learn about functions, domain, range, and proportionality. These words may be familiar to you, or they may be new, or maybe they are matching new vocabulary to concepts that you already know. So what we need to first figure out are some definitions. We'll draw some pictures. And then our goal too is to represent functions through tables, graphs, formulas, and words, like verbally, being able to describe functions. And our third one is using domain, range, and proportionality to describe functions. And lastly, if given a function, can you state the domain and range? Now, online students specifically, this beginning task, you do not have to do. This is a Desmos activity that requires two people to be online at the same time. So this will be for in-person students. So let's talk vocab. So a function is just a rule, and a specific rule that takes certain numbers as inputs and assigns each to a definite output number, which means each input gets only one output. Okay? And a common way to visualize this is through a function machine, which I believe is linked at the bottom of this page. So essentially it's just this fake little machine. We're going to call f of x, which is a symbol for function, f for function, f depending on x. You also may see g of x or h of x. And you get certain inputs. Input. And each input lets out an output. And each input only lets out one output. But maybe you have two different inputs that lead to the same output. That's okay, as long as each input only lets out one output. One and one. Now, you may have heard different words for these, which is good because there are different words for these. Input, in terms of our coordinate plane, our Cartesian coordinates, input aligns with x and output aligns with y. Typically in science classes, these are dependent and independent variables. X is your independent variable, and y is your dependent variable. Okay, now, maybe some new words? No, this might not be new to you. So we've got domain and range. Domain are your inputs for a certain function, and range are your outputs for a certain function. So the domain is a set of all input numbers of the relation. So it's all possible x values the function takes on, okay? So this is also, another word is domain. So we have 4 words for the same thing. And that's just the way it goes. All right, and then range is our outputs for a certain function. So if I say describe the range for a function, you would just describe all of the possible outputs, which we will talk more about later in the notes. Okay, and then lastly, we've got proportionality. So y is proportional to x if one variable increases as the other increases, or as one variable decreases while the other decreases, or as one increases while the other decreases. Just we're looking for the same rate here, at the same rate, which is essentially going to be linear. They're very similar, this word proportional and the word linear, just a line. But the key is the intersection. So the key is we're starting at this origin, and it's essentially just going to be a line. So it might be here, it might be going this way. But yeah, proportional is just increasing same rate x and y, or decreasing same rate x and y. All right, let's go do some examples and talk about. Oh, sorry. Here's a game. If you're not working online, I would check it out. It's especially if you're struggling with the concept of function and what is a function. It's sort of a game where you find the function that matches the inputs or outputs that you're given. Just a nice little practice tool. So do a few of those and then come back. Okay, so let's talk about the second objective. I can represent functions through tables, graphs, formulas, and words. Okay, so I'm going to give you words to describe a situation, and then we're going to talk through a table. We're going to talk through a formula. We're going to graph it, and then I also have you describe the domain and range down here. That's all we're doing for this example. Okay, so at a store, carrots cost $2.50 a pound. And that would be all you need, but I did add this other sentence that says, the price the customer pays is dependent on how many pounds of carrots that he buys. So right away you can already say, what is your dependent variable? What is your independent variable? In other words, what are your inputs and what are your outputs? So the price is the dependent variable, which is y, which is your output. So I'm just going to throw the price over here, which means our input are the pounds. So I'm going to write that here just so we can keep track. All right, so what are our options for the inputs? Can't be negative. Can't buy negative pounds of carrots. That would be like you giving the store carrots. And I don't know, maybe some of you farm carrots, but that would actually be pretty cool. I would buy some carrots from you. Anyways, so input. I guess you could go into the store and buy 0 carrots if you really wanted to. So if you buy 0 carrots, 0 pounds of carrots, excuse me. What's your price? That's 0. All right. You can buy 1 pound, 2 pound, 3 pound, 4 pound, 5 pound. If you buy 1 pound of carrot, what's your price? $2.50. I'm going to throw a $sign here. Wow. So I don't have to write $signs in my table. Then if you buy 2 pounds of carrots, then we're going to pay $5 because that is 2 1 pounds. So we double it. And you probably already picked up the pattern here. This is $7.50. And this will be 9. No. I can count by quarters. $10. And I got $12.50. I said count by quarters because this is how I count anything with a 2 and a 5 in it, is by quarters and then adjusting the decimal accordingly. Okay, so cool. We have a table now. Now we can write a formula. There are lots of different ways that you can think about this. Yeah, when we're in class, we'll talk about it, but for you online students, you can think about this a number of ways, and I just want to preface that. So one way you can do is figure out the interval, first of all, which is just 1 on the x, the input, 1, 2, 3, 4, 5, and then find the rate over here. So this is plus 250, plus 250, plus 250. Same. I'll just do all of these for the same, which means that is your slope. So that means our pounds price. Okay, so price, we'll just call this a $sign. The price equals, because I can use a $sign for a variable, because a variable is just a symbol to represent an amount of value. So instead of using a letter, I'm just going to use a different symbol, a $sign. And then we'll throw our slope in there, which is 250, or our rate. Slope and rate, that's a concept that is heavily used in calculus, knowing that slope is the same as rate. Okay, 250 times the number of pounds, P. So that would be our formula. All right, and now I'm likely going to have to erase because, yes. And now we'll graph it, but I'm actually just going to let you go ahead and graph that on your own or use Desmos to graph it. I will have you sketch curves in here, sketch graphs, but I won't have you plot points because we have online tools for that, and that's a skill you learned a long time ago. So go ahead and use Desmos to graph this if you wish. It'll be a straight line, the rate 250 with a slope of 250. So actually here, I'll graph it. So we can talk about domain and range. So we're going to do y equals my goodness, 250x. And I'm going to get rid of these. Okay, so let's talk domain and range actually while we're here. So domain are all the possible x values on this curve. But keep in mind our situation is carrots in a store, which means that we're going to start at 0. And there is probably a top limit, which what the store has, but we don't know it. So we're going to say that our possible domain, our inputs, is 0 to infinity. And there are lots of different ways you can write that. So you can go ahead and write this in your notes, but I'm just going to write it here. So you can write domain 0. It's a bracket similar to a parenthesis. This means that 0 is included in the set. So we can do 0 to infinity, open bracket, because infinity it's not included. Infinity is not a number. Or you can write it as, let's see, x is going to be greater than or equal to 0. You can write it that way too. Or you just use your words. X is greater than 0. You can write that out too. I'm okay with whatever method you prefer. All right. And now range. Total number of carrots. Again, we're not going to buy less than 0 pounds of carrots because that would be us giving the store carrots, which means our range actually isn't this portion of the line down here. So our range is also the same. It'll be 0 to infinity. 0 to infinity. But this is going to be y instead because range is y. So y is also greater than or equal to 0. So that would be your domain and range in this situation. Cool. So let's go on. Let's talk about proportionality. So the problem we just did with the carrots, that was proportional because y is proportional to x if there is a constant k, so just any number, k is any number, such that y equals kx. In our problem with the carrots, that k was 2.50. And the variable k is called a constant proportionality. That just means that the rate, that x and y are related by a certain rate. And then here's another example using apples, but it's really the same idea. So formula to describe the situation of apples. Apples are 60 cents a pound. And we're paying in p cents. Okay, so this is actually 60 cents instead of $0.6. So we're going to write a formula to describe the situation. Let's see, so let's do price we pay is p. So let's say the price we pay, p cents. Okay, so this is p equals, it's going to be 60 cents a pound. So this is 60, because remember we're in cents, so it's not 0.6 because that's dollars. So this is 60 cents per pound, and this is W pounds, so 60W. And if you want to, this is actually an equation, but you can also say this is equal to a function with respect to W. So you can write this either way. P equals 60W or F of W equals 60W. All right, in the apple situation, what's the value of K? 60. And then what does this value K mean? It's the slope or the rate, to put it in very short terms. It's the relationship between X and Y, the rate. Okay, okay, domain in the situation and the range. Well, if you wrote it down. So let's see, it was P equals 60W. So again, you could buy 0W, so they, for both domain and range. For this one, yes, it will also be 0 is included to infinity. This is a hard bracket. Okay. All right. Well, sorry, y'all. I guess we're going to write in red now and have some technical difficulties. Okay, and we're on. Let's go. Okay, lastly, finding the domain and range in situations that are maybe a little more complicated than a linear equation. So we got this guy, just a graph. Let's talk domain and range. As you can see, okay. Wow, I was about having to just type it. Okay, so A, domain and range. Remember, domain are all the possible x values this graph takes on, all the possible inputs, all the possible x values that will get you an actual y value. So let's do x. I'll write it as an inequality this time. So for x, the domain, x can go into the left forever and ever, which is negative infinity, up to 0. You see, this is called a vertical asymptote, and that's just a line that this graph will never ever cross. So this is just a line the graph never ever crosses. Wow. Imagine that's a straight line. Okay, so this means that x will go to so x is going to be less than 0, but not including 0, because it doesn't include 0, forever and ever. Then it does the same thing just on the opposite side, so it goes to infinity, but it still doesn't touch 0, so that means x is also greater than 0. Now you might say, well, Ms. Anton, the domain or the range looks a lot the same, and you're right, it is. So the range is also y is going to be greater than 0 because it goes up forever and ever and ever. But notice here, it doesn't touch 0, so it has to be greater than 0, and then y is less than 0. Excuse me, y is greater than 0. All right, B. For those who have taken trig, you may recognize this is a sine curve. For those who haven't, we're going to cover it in this functions chapter, so you will learn it there. And for those who did take trig, but maybe you've forgotten would like a review, you're going to get one. Okay, so domain. Domain. What are all the possible x values? You might see that there are no breaks or gaps or anything in this graph. It goes on forever, so that means the domain is just all real numbers. Just a reminder that a real number is just anything that's not I in imaginary numbers. This is integers like 1, -1, 0. It is rational numbers, fractions, pi e. Irrational numbers is pi e. Just anything that's a real number. Okay, and now the range. How high does this graph go and how low does this graph go? Not forever. You might see that it fluctuates between a 1 up top and then a -1 down bottom. So that means x is between -1 and 1. Okay, and now we can graph these two, C and D. I would suggest that. It's pretty straightforward. So C, x squared plus 2, I actually have that graphed over here. All right, so I'm just going to go ahead and write the domain and range over here. So the domain, all the possible x values, is all reals. It goes to the left forever and ever and to the right forever and ever. Now the range is not all reals because notice it doesn't go down forever and ever. It's got this bottom point, which is 2. So that means 2 is less than or equal to x. Sorry, y is less than or equal to nothing. It goes on forever and ever, which means we don't need this one over here. So that means just 2 is less than or equal to y. Okay. Now our last one. Y equals 2. Domain and range. How far left and right does this graph go? That's the domain. Goes on forever and ever, all reals. Now the range, how high up does it go and how low does it go? It doesn't go high or low. It stays at one single point, which just means y equals 2 is the whole range. 2 is the whole range. Okay, and that's what we're covering for functions. That's the end of the notes. Oh, I did do that. Okay, excuse me. Let me fix something in these notes. This should not say x for the range. This should say y. The numbers are right, -1 and 1, but this should say y. My apologies. Okay, so that's it for functions. What is a function? Domain, range, proportionality. Email me if you have any questions at all, okay? Have a good day.